All right, welcome everybody. Good evening, good afternoon. Welcome to the session on Microsoft StreamInsight and complex event processing with SQL Server 2008 R2. My name is Thorsten Grabs. I'm the lead program manager for StreamInsight, working for Microsoft up in Redmond. And what I want to accomplish today is, first of all, I want to explain to you what stream data processing is about and why complex event processing is important. And then I want to introduce you to StreamInsight as a technology, as a product, walk you through a couple of the key use cases that we see for the technology, walk you through a couple of demos as well so that you get an idea of what it takes to build a StreamInsight application. And then also go into a couple of the new things that we are rolling out in the next versions of StreamInsight and talk about that as well. So having said this, let's get right into the question, what is stream data processing about? How does it relate to the database technology that we all know and love from SQL Server, and how is it different? And the scenario that I picked to introduce you to stream data processing is somewhat related to cars and traffic, and we'll revisit a couple of times. So let's start with a very simple question that I want to ask about cars. And I have a parking lot in front of the building, and I want to understand how many red cars do I currently have in my parking lot. If I use a relational database system like the SQL Server Relational Engine, that's a very straightforward question to answer. And depending on the different execution algorithms that you get, it would look like something. I walk out into the parking lot, I go through the rows, I count the red cars, and I compute my answer, and I deliver it back to the consumer or to the application. If I had to write a SQL statement for that, it would look something like this, where I go into a table, and I have a couple of predicates that I evaluate, and I return an aggregate back. So far, so good. So that's very simple. And databases are very good at that, and it's a very proper technology to answer these kind of questions. Now let's start to change the question that we want to ask about the data in a couple of very interesting ways. So let's continue to think about cars, but imagine you are right next to the I-80 interchange down in California, and you want to find out which cars are taking the road to San Francisco. So you're standing right there, and in addition to that, you also add a temporal constraint to your question. Here, it's what happened in the last hour. How many cars, how many red cars have taken that interchange towards San Francisco? And that's a very important, very critical change that we have made to the question that we are asking about the cars and are asking about the data that we have around cars. If I again went ahead and wanted to answer that question by using a relational database system, the implementation behind that could look like, oh, every car that comes by, I pull it over into a parking lot, I ask it to stop there in the parking lot until the end of the hour. By the end of the hour, I walk through my parking lot, I compute my count, and I return it back to my users or to my application. Obviously, that's not a great approach for multiple reasons. And the most prominent one is, obviously, the drivers wouldn't be happy to be stuck in a parking lot until you've done your driving. So what would be a better way to accomplish this task, to answer this question? And a better way would be less intrusive, where we don't ask the cars to stop at the side of the road. And that's a very typical requirement that we have for stream data processing, where you're injecting yourself into a pipeline. Typically, data is flowing through that pipeline, and then you don't want to stop the data flow, but still, you want to keep answering interesting questions about the data that is in flight, that is flowing through your pipeline. And these are the typical questions that are very well served with by complex event processing engines or by stream data processing systems. So coming back to the example that we had on the previous slide, how would an intuitive implementation behind that question, how would that look like? Here in this case, we would just sit right next to that I-80 interchange and just count the cars as they are driving by and checking off whether they're going to San Francisco or not. And the interesting aspect to that is it's very lightweight. I just need to keep that counter basically in my notebook, and for every car that comes by, I keep bumping that counter. And whenever the user asks, I can deliver the current count to it. And in particular, at the end of the current hour, I can deliver that result to the consumer, to the application. One key property here is that I'm actually stretching the calculation across the last hour. So whenever a car drives by, I'm doing a little calculation so that when the end of the hour comes, I can deliver the result very efficiently to whoever needs it. I'm also in a position to actually deliver an updated result, an updated counter for each time a car passes by. And that is very typical for these stream data processing questions and stream data processing scenarios, that you want to look at the data, and you want to do that while the data is in flight without putting the data at rest necessarily in a database system. Now, given these scenarios, let's start looking a little bit into StreamInsight and how does it help you as a technology to build applications around these kind of questions where you want to analyze streaming data, or you want to process data while the data is in flight. So first of all, from a positioning perspective, we're positioning StreamInsight as Microsoft's platform to build applications for streaming data, to build event-driven applications. The key properties that this platform, that the engine for StreamInsight provides you, is exactly the continuous processing. So while the data is coming in, I keep updating the results that I want to compute. And we're doing that in a very efficient way by using incremental processing whenever possible. That gives a couple of key characteristics. So you can achieve a very high throughput, so tens of thousands of data items that need to be processed per second. And we can deliver results with very, very low latency, so in a fraction of a second, for instance. All the calculations that we do are event-driven. They follow a push model. So as new data arrives in the application, in the system, we automatically trigger the necessary calculations to update the results that you are calculating. In terms of the development experience that we are providing, we are tightly integrated into .NET in Visual Studio. So you use LINQ language integrated query to formulate your queries, rules, patterns, the questions that you want to ask about your data. The adapter model and framework that comes with the product allows you to connect to different data sources and data sinks depending on your application scenario. And since it's an engine, we also give you an interface that allows you to manage and to administer the system. In addition to that, an extensibility model in .NET gives you the ability to also link in and use proprietary libraries that you have in your .NET ecosystem. Last but not least, it ships under a SQL Server license. So it's part of Microsoft's data platform. And in most of the SQL Server editions, you'll find a flavor of StreamInsight. I have a slide at the end of the presentation that tells you a little bit more of how the product differentiates between the different SQL Server editions. So let's take a step back from the concrete example around cars and try to understand a little bit more deeply why these scenarios are so important. And I've put together this slide here that actually shows you a chart with two axes. On the x-axis, you have the time horizon that you want to apply to analyzing your data. And on the y-axis, I'm trying to plot the value that you are deriving as a business from the data that you're working with. And obviously, there's scenarios that we're very well familiar with. For instance, think about the quarterly sales report that you pull once a quarter, a couple of days or weeks after the quarter has finished. You look into the sales information that you have for that quarter, and it's not critical that the report finishes the very second when the quarter closes. So the time horizon for that is fairly comfortable. You get a couple of days, if not weeks, to run the report, and the report stretches over several weeks, if not months. And those scenarios are very well served with the existing products that we have in SQL Server, SQL Server Relational Engine, the BI stack, analysis services, reporting services. Now let's start working these curves a little bit, and let's tweak the time horizon. So let's imagine that we're in a manufacturing plant, and by the end of the day, we have to do the forecasting for the next day. In order to do that, we want to look at the inventory that we currently have, and based on the inventory, we have to look into the production plan and then provide a forecast for what's the new inventory that I need to get into the plant so I can successfully complete the next day. So that becomes a little bit more intricate for various reasons. So first of all, I'm probably just working with the data that I have acquired today. So what's my current inventory at this point? So my time horizon has shrunk. Also, it becomes more critical for me that I actually complete the report before the next production day starts. So I have to make sure that the report finishes within a couple of hours so that I have enough time to replenish my inventory. So in these forecasting scenarios, I'm already working towards the right here. And again, SQL Server and the existing products that we are very familiar with typically do a very, very good job on those scenarios. Now let's move these curves even a little bit further. And we start seeing very interesting scenarios here as well. But let me first talk about the shift of the time horizon. And these scenarios are typically characterized by very, very short windows of time that you're working with, so seconds or minutes of data in many cases. And the latency requirements at which you have to do the analysis of the data, they become very strict. And we see this in financial services, for instance, where you're plugging into data, ticker data that's coming from a stock exchange. And within a fraction of a millisecond in many cases, you want to find out whether a particular stock follows a certain pattern. And if that is the case, immediately trigger a certain action to buy or sell a stock from your portfolio. So that's a very, very time-critical scenario, particularly in financial services. Another one that's very, very important for us at Microsoft is around clickstream data processing and web analytics. So all of our online properties are instrumented so that all the clicks that you are doing on Bing or Hotmail are sent into an actual StreamInsight engine for processing, so that for each online user, we build an understanding of what is that particular user interested in. And based on that interest that we find out, within the current browsing session, we want to decide what are the most appropriate advertisements that we can show to that particular user. And obviously, we have to make that decision in a couple of seconds before the user goes to the next page. So again, we're looking at a number of clicks over the last couple of minutes, sometimes even days. And based on that, within a second, we have to decide what are relevant advertisements. And only if we're actually meeting those requirements around the latency, then we can deliver value to the users of this application. There are other scenarios, for instance, in power grids, smart grids, healthcare, outpatient monitoring, varying sensors and devices. Lots of these scenarios have to deal with digitally born data. Think about users carrying phones, cell phones. They're producing a ton of data, location, position of the user that you can use for your applications, and where it is critical that you react in a timely fashion. So how do these systems typically look like that deal with processing of this kind of data? And this is a busy slide, so I'll walk you through that in a couple of steps. So the data sources are on this slide on the left-hand side, and this can be all sorts of data that comes from devices or sensors, digitally born, can be clickstream data that we're getting from web servers, can be, as in the financial services example that I just explained, can be data that we're getting from a stock exchange. We are acquiring that data through some sort of a data bus, and then we are sending it into our systems to do all sorts of processing. The lower part is the one that we understand very well and that we're very familiar with. We are sending it into a relational database system. At some point, it goes into analysis services cubes, and then it goes into the BI stack with reporting services and so on. The upper part is the more interesting one, where from an operational perspective, we want to analyze the data, understand what's going on in terms of business operations in my organization. And in many cases, I also want to be in a position to automatically make decisions. And if I overlay this with the different products from the Microsoft stack, there's a number of different products that serve these areas very well. Lots of them are coming from the SQL Server ecosystem. The area that is currently still blank is the one around operational analytics and automated decision making. And this is exactly the place where we are positioning StreamInsight to help you build these applications, where you acquire the data from the data buses, from the data sources. You start analyzing the data while it is in flight, and you push the results out to various different consumers. And that can be a Silverlight dashboard that just shows you in close to real time what's the state of my business operations, but can also then be the BI stack with reporting services and analysis services on top of it. And I'll show you in a couple of demos how you can actually build these end-to-end systems. So that's the busy slide with lots of moving parts and lots of components in there. The key takeaway here is really that for many of these scenarios, you really want to follow a push model where from the data sources all the way to the consumer, you're pushing the events through the system, and you follow that event-driven architecture. So how is that event-driven architecture different from the typical traditional database applications? I try to confront the two here on this slide. So on the left-hand side, you have the typical database application. And if you think about various characteristics for that, you'll find out that the querying paradigm is request-response. I submit a transaction, I submit a report, it does its processing, and the result comes back to me, and I'm done. In terms of the key performance metrics that we're looking into for database systems, it's around response time and throughput. And depending on what system setup you have, you might have response times in the order of seconds, maybe minutes or days for long-running reports. And transaction rates are typically in the thousands of transactions per second for large systems. The underlying query semantics that people use are the relational algebra semantics. Now, on the other hand, let's look into these event-driven applications. The querying paradigm here changes dramatically. It's no longer request-response. What you want to have instead is a continuous querying paradigm, where you submit your query for processing, it stays in the system, and it keeps calculating and updating the results until you tell the query to stop. And that's a key shift. So that's why continuous query processing is so important. In terms of the performance requirements, the key metrics there are around what we call latency and data rate. So latency means as soon as a new data item arrives in the system, how long does it take until I see it reflected in the results that the system produces for me? And for many applications, they have very strict requirements. There can be a fraction of a millisecond that you need to accomplish to push the data through those analytics, through those calculations. And again, depending on the scenario, the other metric, which we call data rate, which is the number of data items arriving at the system every second, can also be very challenging. Tens of thousands, if not hundreds of thousands, of items that need to be processed per second. Now, looking into the query semantics that underlie the questions that you want to ask about the data, here, again, we're looking into a flavor of the relational algebra, and that's also the approach that we have taken for StreamInsight. We started out with a relational algebra, and we then started thinking of what are the adjustments that we need to make in order to make this useful for customers to write their queries and answer their questions about the data. And the key addition that we have made to the relational algebra is the ability to work with time. And if you remember the initial example with cars going through the I-80 interchange in California, we had an example of that. We were looking at the past hour to do the calculations. And that's an example of new temporal processing capabilities that you want to have when it comes to dealing with streaming data. So those are a couple of the key differences between the typical relational database applications and these new event-driven streaming applications. If we just take two of these characteristics, latency and data rate, and plot a two-dimensional space, you have a large area that's covered well, served well with relational database systems as the underlying platform. But as soon as your latency requirements go beyond a certain point, or your data rate exceeds a certain point, then typically relational database systems struggle to deliver on the requirements that you have for those applications. Just to walk you through a mental example for that. So think about tens of thousands of new rows arriving in your database system. You persist them in your database, you store them, and at the same time, you continuously run the same report that you want to update every second. So that leads to a lot of contention in your database system. And that's the reason why database systems, as soon as you exceed latency or data rate requirements, are no longer necessarily the best platform to deal with this kind of processing. And there are a number of scenarios that fall into that bucket, and we'll go and have a look at some of them in later slides. So let's scratch a little bit on the surface for StreamInsight. So what is the product about? How does it look like? What's the experience that you should be prepared for if you want to use that product? The slide that I have here is structured into two parts. The first part is the top part that describes the development experience that you get when you are building a StreamInsight application. The bigger part, the lower part, is a StreamInsight application at runtime. Let me start with the top part, the development experience. One of the design decisions that we have made fairly early on was to tie it closely to development tools that you are familiar with. So what you're going to see is you write your StreamInsight application in .NET, you use C#, and you express the questions that you want to ask about the data in LINQ, which stands for Language Integrated Query. And once you have written that application, once you have expressed those rules, those questions in LINQ, we take those LINQ expressions from your application and send them down into the StreamInsight engine, which takes us from the upper part here in the slide to the lower part, which is StreamInsight at runtime. And once you have built such a query in your application, and it gets deployed into the StreamInsight engine, and you start it, it starts consuming the data from the different sources that you have provided to the system, to the query, and starts its processing. So the data flows from the left to the right through the query logic, the red boxes that you have there. And then eventually, as results get produced, they are sent to the consumers, to the event targets. And there are a couple of key connectivity points along the way that are called input and output adapters here on this slide. And those are the key pieces that allow you to connect to all sorts of proprietary data sources and data sinks. StreamInsight gives you a couple of built-in ones, in particular ones that are very popular in .NET. For instance, .NET sequences, IObservable and IEnumerable, are some of the adapters that we support out of the box that give you access to a lot of data sources and data sinks. In addition to that, there's also an SDK that allows you to build adapters for proprietary domain-specific systems. Okay, in terms of the overall architecture, so it's an engine that can run separate from the client application. That's one of the deployment models that we support. Another one is more lightweight, where you can embed the actual StreamInsight engine into your client application process, which is a very lightweight deployment model. And we support both of them. Wrong way. So let's look at a couple of the scenarios that we support with this design, with this architecture, with the product. And the overarching picture that you will see across lots of these scenarios is that a first step typically is I need to instrument my data sources so that I can acquire data from them. That's the first step. You start monitoring your actual raw data sources. And as the raw data comes in, you squirrel away small histories of that data that you're acquiring from those data sources. And based on that, you're coining your initial questions that you want to ask and that you want to use to drive your business, which takes you into the next step where you're starting to manage your business based on those initial KPIs that you have designed. And once you're more comfortable with that and that's running smoothly, then you can actually incrementally start to improve those KPIs, those rules that you're using to manage your business in close to real time. And that, again, takes you back into analyzing the historical data, reason about creative changes that you want to apply to those business rules that you're running in StreamInsight, and then you can go and update the current business rules and replace them with better ones that give you better business benefits. And there are a couple of trends in the industry that allow us to do that. So a lot of data just becomes available for free. Just think about the phones that are providing all this data about users that could be your customers. So data acquisition is becoming much more cheaper. Also, storage costs is going down. And as long as you don't have to go through an expensive load process for the data, but can analyze the data without going through that load process, it might be actually feasible to extract some meaningful information out of the data in a very cost-effective fashion. And that's where complex event processing and stream data processing helps you, because it's this non-intrusive way to analyze the data while the data is in flight without necessarily storing all of it. So in terms of the components involved, I have a couple of slides later, then more detailed information about the different verticals like manufacturing, web analytics, smart grid, and so on. First step, you instrument your data sources. You have some sort of a data store or archive where you can collect histories of the data. Based on that, you design the rules and patterns that you roll out into your event processing engine like StreamInsight. You might want to correlate this with more static data that describes your customers, your pieces of equipment. And based on that, you put together your end-to-end application, which may or may not involve more visual components that show you dashboards or KPIs, or that are just silently taking automatic actions like selling or buying a particular stock. Let me walk you through a couple of different industries where this is important. The one that I want to start out with is financial services. And a key scenario here is understanding how markets move, and based on that, identifying what's the risk exposure for a particular financial institution at various different levels in the financial organization. The key challenge here is that financial data is produced in a continuous fashion by stock exchanges. The feeds are very heavy. So if you look into typical stock feeds, and if you include futures into that, we're talking about hundreds of thousands, if not more, data items that are arriving at a system every second that need to be analyzed with very, very low latency. Now think about a trading organization that wants to understand for each trader or for each portfolio what's the risk exposure for that particular guy or for that particular area in the business when the stocks that are being managed from that desk move in a particular way. So the advantage that StreamInsight provides here is you can express these patterns that you're interested in that indicate risky situations for you. You can express them easily in a declarative fashion in LINQ, in language integrated query. The engine helps you to deal with the scale requirements of these scenarios. It helps you to deal with these hundreds of thousands of events per second that you have to process. And it can help you to then notify of a risk situation in close to real time. And the engine actually is agnostic of whether the data that's coming in is real-time data that you're currently getting from a stock exchange or whether it's historical data. So you can use the same queries that you have written once also in backtesting scenarios overnight when you want to revalidate your risk models. So let me walk you real quick through a demo for that. And let me first explain the scenario to you a little bit more. So let's imagine we have a market feed from a stock exchange hooked up to my laptop. So that's not the case here right now. So I'm simulating that market feed. And we're getting ticker information from that feed. We're sending it into a StreamInsight engine that basically for every new tick that's coming in is updating an internal snapshot of the market. And now on the output side, I want to aggregate that information because that's a lot of stuff that's coming in there. I want to aggregate that information and provide a market update every second to various different consumers. The first one that I have wired up here is just a plain Silverlight dashboard that gives a real-time view into the current market conditions for a couple of the stocks. The next one that I then want to show is sending these market snapshots to SQL Server to enable the BI stack on top of that with analysis services in Excel. And the last step then is to do a mesh up between historical information that I store in analysis services and overlaying that with real-time information that I'm getting from StreamInsight. So those are the 3 steps that I want to go through. And along the way, show you a little bit more about the development experience and also what are the various tools around the product that help you to monitor and administer StreamInsight. So with that, let's go in here. And what you see here on the left-hand side is a console application that's running the StreamInsight engine and acquiring the market feed from my virtual simulated stock exchange. And when I start this, you see first it fires up the engine and the query. And then I'm already dumping debug output into the console window every second. And you will see a market update with a couple of aggregates that are being calculated, being sent to the console output each second. The data rate on the input side is about 1,000 events per second. And if we right now just pull up the task manager to look at performance, so this is the console application that is currently running with 1,000 data items being processed every second. And you see that the CPU impact is fairly negligible. So it's close to 0 even. And that's running a debug application right now. And it's not stored in a database. So up to this point, all that's being done is doing the calculations in memory. So StreamInsight does the query processing. It keeps the necessary state for you in memory, so you don't have to worry about state management. And then in a later step, we can then decide what we want to send into the database system to keep it around for longer. So hang in. We should get answered that question just in a minute or two. So far, so good. So all of that is just basically happening in memory. Not too exciting, except for the fact that we're actually dealing with quite a lot of data already. Let's fire up the first consumer, and I have a Silverlight dashboard here on the right-hand side. I can connect this to the running StreamInsight application, and then fire up an output adapter that allows me to tap into the results that are currently being produced by that StreamInsight query. And you can see that the results are being sent over to the Silverlight dashboard in close to real time. I'm using a WCF full duplex protocol to get the data, to push the data over from the StreamInsight engine to the dashboard. So a key fact that you already see here is the continuous fashion of the processing. So I've fired up the engine, I've started a query, and the query is sticking around until I tell it to stop, and it keeps producing the results as data is coming in. What can we do to get a little bit better understanding of what's happening behind the scenes? Let me show you one of the tools that we provide for StreamInsight for developers and administrators to look into the current processing that's happening in their system. The StreamInsight engine can expose a management endpoint that allows you to connect this event flow debugger to the StreamInsight engine. And I'm using that to connect to the running application that I have running in the background that exposes this endpoint. And we can, on the left-hand side here in the Object Explorer, drill into the current metadata for the application. I see that I have an application running here that's called Market Monitor. And I can look into the currently running queries. At this point, it's just a single one. And what I can do by double-clicking on it is pull up the query plan that's running behind the scenes for that query. And you see that we have an input stream that goes through an input adapter, goes through a couple of steps. So we're doing, obviously, a grouping first. And then we have some sort of aggregation happening here before we're sending the results out to the output, to the consumer. Now, there are a couple of interesting things that I can do for these queries. The first one that I want to show here is doing a recording. What this does, it basically taps into the processing that's happening in StreamInsight right now, and it's collecting a trace that I'm acquiring here, and that I can overlay into this query plan rendering that you see here. So what this allows me to do then is to basically look at all the incoming events that were happening during the time when I was taking that trace. And I can watch how they are getting processed and how they're trickling through the system. And there are a couple of interesting questions that I can now answer with this tool. So let's imagine that one of the users is particularly interested in why a certain result gets produced by the StreamInsight query that's currently running. The way that this tool can help is by a feature that's called root cause analysis, where you select an event in the output of the query, and you do a root cause analysis, and that will then trim down the view that you see here to all the events that have contributed to a particular result event that you have highlighted on the output side. And that gives you the capabilities then to explain why a particular output emerged from the system. And there's a symmetric functionality in obviously, which we call event propagation analysis, where you go into the input side, and let's say we're picking this event here, and I do an event propagation analysis, and that then shows me all the various results that this particular event has contributed to. And I see here is about a handful of different results on the output side that got impacted by this input event that I've selected for the event propagation analysis. Besides that, I can also manage the queries that are running. So for instance, I can, let's look into this. I can stop the running queries. I can start stopped queries. I can also pull up diagnostic information for a query. It's very useful, for instance, if I want to understand what's the amount of memory that's currently being consumed by the query, or what's the amount of CPU that the query burns. So let's disconnect this guy. OK, now, besides that, let's start wiring up additional consumers for the data. And what I've done here, the next step for us is to send the results data to SQL Server so that we can do some analysis with the BI stack on top of it. What I've prepared is a SQL Server database with a table that's called market snapshots that has a couple of columns that can hold that data. And you see those here. And if I just query that table real quick, you see it's empty right now. What I can do then, without affecting the query that's currently running, I can fire up an additional output adapter that will send the results from the StreamInsight query into this SQL Server table. And you see the first 100 rows made it into that table. We're at about 160 rows. So every second, I'm sending about a dozen result rows into that table. And that then allows me, for instance, by the end of the day, to rebuild or to send this new data into an analysis services cube. And that's what I've done here. I have an analysis services cube with market snapshots with various different dimensions. What country does the stock tick come from? What's the stock exchange, the market? What's the ticker symbol, timestamp? And then numerical data around what's the pricing, what's the volume for those ticks. The way that I can use this analysis services cube is, for instance, to go into Excel and insert a pivot table. And I've prepared a connection already to that analysis services cube. And that's just regular Excel up to this point. And I can pick a particular stock exchange for the columns. I can pick a ticker symbol. It goes into the rows. And then let's just pick some pricing to go into the values. And you see that's a regular pivot table. And if I refresh it, I will get the same data because I haven't updated or rebuilt my cube yet so far up to this point. So that's a static analysis services cube. Now, if I'm interested in making this a more real-time experience, the first thing that I would want to do is, for instance, to enable what-if analysis so they can actually make changes to the content of that pivot table that we are currently working with. Let me do that real quick and also enable the automatic recalculation here. And then I've written a little plugin for Excel that allows me to connect to StreamInsight, to the query that's currently running in the background, to consume result data from that query and overlay it with the pivot table that we are currently looking at. So let me connect to the StreamInsight engine that's running in the background here. Hope that everything works. So it says connected. And let's start synchronizing the table. And you see that the cells are starting to change and starting to move. And that's because new results are trickling in from StreamInsight. And I'm overlaying them into that pivot table here. And based on the dimensional information that I'm getting from StreamInsight, I know which cells to go to in the Excel spreadsheet to do the update in the pivot table. And I can also stop that to make changes to the pivot table. For instance, I might be interested to also get the actual country from the stock exchange into the picture. And I can restart the process. And we'll see those updates getting reflected. And note that also the aggregations, the totals, are being recalculated. That's because I enabled the automatic updating capability for analysis services. So whenever I make a change in the pivot table, I fire off an analysis services query that recalculates these grand totals that I see here. All right, good. Let's look a little bit behind the scenes to understand what is actually going on. What would it take to write an application like this? Let's switch over into Visual Studio and see what are the key steps involved into building an end-to-end application like this one. And the key steps that you have to go through, and that's pretty much the same for every StreamInsight application that you need to build. The first one is you just create a project in Visual Studio, and you add references to a couple of assemblies, Microsoft.complex event processing assemblies. Those assemblies provide the StreamInsight framework, the SDK, for you. And those are the ones that you will be working with. And after that, the next question that you typically go through is, how should I structure, how should I represent the event data that I'm acquiring from these different data sources? And you see this here. So it's a totally .NET-based experience. It's just a regular class that I'm using here to define a quote structure with a couple of string attributes to it, like the ticker symbol, the stock exchange that the information is coming from, and then various different numerical attributes around prices and volumes. So that's the next step after adding the references, is defining your event data structures on the input and the output side. There was a question in the back. It's your choice. It can be console application. It can be a WinForms application. It's really it's very flexible. It's up to you. Silverlight does not work, but everything that goes back to the regular .NET stack, .NET 3.5, Service Pack 1, or .NET 4.0 will work. So right now we are at this point where we have defined the structure of the data sources on the input side. We have this quote structure here. Then the next step that you typically take is, based on these structures on the input, I want to define a stream where all of the input events have the shape of this quote structure. And that's what I've done here. So I'm using this quote structure, and I'm plugging that into a complex event processing stream, and I call it quote stream. And that's the input stream that I'm working with. And that's the piece that I use to then write the link query over. And that's what you see here. Using this quote stream for every reading that I'm getting from the stock exchange, let's first do a grouping where I'm looking into the ticker symbol, the stock exchange name, other attributes, to partition the incoming data feed into different groups. And note that this is dynamic. So whenever a new group ID occurs in the input, StreamInsight will automatically take care of creating the necessary groups for you internally and managing the state for them. So you don't have to worry about that. That's totally dealt with in a declarative fashion by these link queries that you submit into the system. So now we have a couple of these groups that are getting created and deallocated based on the activity that you have in your input data stream. And the next step that I'm using then here is using one of our temporal additions to the relational algebra, where I'm using a hopping window, that's one of our window constructs, to look at events as they occur over time. So think about events occurring over a timeline that stretches from the left to the right. What windows do is basically chopping up this timeline into segments, and then for each segment, thinking about the events that fall into that particular segment, and then doing calculations over those. Typically it's aggregations that you would want to do. And there are a couple of different types of windows. The hopping window comes with a size of the window that you use and a frequency at which this window moves. And that is very handy. For instance, if you want to compute a moving average, you tell us how large the window is going to be that you want to do for your moving average. And then you also tell us how frequently, how often you want to recalculate that average. That's a hopping window. There are other flavors, like a tumbling window, where the windows don't overlap. They're completely event-driven windows where as an event comes in, you look back a constant period of time. All of those are supported as built-in constructs from within StreamInsight. Here in this case, I'm just using a hopping window, a very simple one. And then for each of the windows, I'm doing an average calculation for the numerical fields. That's what you see down here. So for all the numerical fields. And then I'm also outputting the grouping keys. And that's the result that you see that we are sending into SQL Server and into the Silverlight application. So that's, in a nutshell, all the magic behind writing a StreamInsight application. You include the assemblies, you define your event structures, you write your link queries, and then the last step after that is taking that link statement and connecting to the StreamInsight engine through the API and sending it down for processing to the StreamInsight engine. OK. See, the query is still running. It's a continuous query. Let's switch back. So I think we covered all of these scenarios here. And let's move on and look into a couple of additional scenarios. And before I do that, I actually want to take a minute to introduce you to the next version of StreamInsight, which we call StreamInsight 1.1. And one of the questions that you may have run into as you saw this previous demo is, what happens if somebody pulls the plug on the box and if the system goes down? Might be that I have to just install the next updates for the Windows operating system, or just might be a power outage that I'm experiencing. And depending on the queries that you've put in place, you can actually acquire a lot of state in your StreamInsight engine that might be very precious to you. So you might not want to lose that state for these applications. And that's one of the key value adds that we've put into the next version for StreamInsight for on-premise deployments. And that's one of the key benefits, that we're giving you a resiliency feature that allows you to checkpoint your currently running queries to persist the state down to disk. And if you have an outage, then bring the system back up again and recover the state from the checkpoint that you have persisted. So that's one of the key features that we are adding to the next release. And in addition to that, we also made a couple of improvements to both the developer experience and the administrator experience. The first one is around predictive modeling and working with statistical pattern matching, for instance, where we are introducing a new user-defined stream concept that makes it much, much easier to implement these scenarios. One of the key customer feedbacks, key customer asks, was around enabling performance counters for the StreamInsight engine, so we're adding that in the 1.2 release. And besides that, there are various rough edges in the Link experience that we had for developers in Link, so we're fixing a lot of those as well. We're planning to have the 1.2 release ready by June, so next month, and in English, and a couple of weeks later than the localized versions in the other 10 languages that we support. And that will be continued to be licensed through SQL Server 2008 R2. So moving on to other scenarios that I want to go through as well. The next one, and we talked a little bit about this already, is web analytics. And the scenario that I was mentioning that is very important for us at Microsoft is around what we call real-time behavioral targeting. Again, all our online properties are instrumented. Every click that you make on Bing, Hotmail, MSDN, Shopping is sent into a StreamInsight engine that deals with about 500 million events every day. And we're using that to understand the current behavior of our users to make sure that the advertisements that we show are the most relevant ones for the current user behavior. And again, one of the key challenges here is to scale that system to a user population that's hundreds of millions of users in total. And at any given point in time, there are tens of millions of users actively navigating our online properties. The way that this has been dealt with previously was that all these clicks were persisted in log files, and then by the end of the day, these log files were shipped into a big process that took about 2 to 3 days. And at the end of these 2 to 3 days, we then understood what was the current interest of our users 2 or 3 days ago. So think about a couple of scenarios, like, for instance, pizza delivery. That wouldn't be good to place pizza delivery advertisements 2 or 3 days later. The people would no longer be hungry. So you want to understand this in a much quicker fashion. And that's what they can do now with StreamInsight, where they get this kind of information in a fraction of a second and can reason about what's the right advertisement to show on the next page. So, and again, a lot of that is around having the ability to continuous queries, to do continuous query processing, and to push the events through the system as they arrive. I also have a little demo around this just to illustrate this real quick for you. So, wait a sec. Get this fired up here real quick. And the overall setup is fairly similar to the previous demo that we have seen. We have a console application here on the left that's just starting up right now, and a Silverlight dashboard application on the right-hand side. So imagine that you're running a web server. We're getting all the information about the clicks that users are making, including the IP addresses from which the requests come. So wouldn't it be nice to understand which regions of the globe or the US are producing the most traffic for you? And that's kind of what this demo scenario is all about. So we have this server sitting in the back, getting all the clicks with the IP addresses. And once I start the dashboard, we'll see that the map of the United States here lights up with a color coding. And right now, everything is fairly light red, which is a good place to be. And let me make this a little bit larger here. And there's another view here where you see the currently most popular pages on my web server, and the top 5 with the number of page views in the last couple of seconds is also shown here. And you see that this continuously updates. So every second, we're getting a new page count here for that control. And let's start increasing the number of incoming events a little bit here. And that will take a little bit to become effective. But you see that the event counts here in the page view are getting up and up and up and up. And you also see that the color coding of the map is changing. So you see that, for instance, obviously California is very active right now. Texas is getting active. And here up there, that seems to be Montana. So as the load is increasing on my system, I'm seeing this in close to real time. And I can then take action, for instance, fire up additional servers to accommodate for that increasing load that my web servers are experiencing. So that is a simpler scenario than the one that we have enabled at Microsoft behind our online properties. But just to illustrate this concept for you, now everything turned red. OK, so that's a very simple example for understanding online user behavior and reacting based on that. And all of these analytics that are powering the dashboard here are StreamInsight queries that are running in the background, doing the aggregation and the grouping for the heat map of the United States, and also the most popular page view down here. So obviously, a key scenario for, or a key deployment scenario for these kind of web analytics scenarios would be Windows Azure with worker roles or web roles. And that would be a very compelling place to run a web application. Now, the next announcement that I want to make at this point is around support for StreamInsight on the Windows Azure platform. And we're currently calling this project with codename Austin. And the key value proposition here is to make StreamInsight complex event processing services available in the cloud as a cloud service on Microsoft's Azure platform. The key benefits for that are that you will get the elastic scale and better total cost of ownership benefits from Azure for your complex event processing application. And think about the scenario that we just looked at. If you're already running your web application from Azure, why would you want to send all the clickstream data to a StreamInsight engine that runs on premises just to do the analytics over it? Why wouldn't you rather want to run that analytics, the clickstream processing, in the cloud as well? And with these capabilities, we will give you exactly that deployment experience. To make it easy for you to bring your applications to the cloud, we want to make sure that the development experience that you have for on-premise development is as close as possible to the one that you get in the cloud to make it easy for you to migrate your applications. Right now, we are in a place where we're doing private CTPs with very few customers, and we're going through the initial customer feedback. And based on that, we'll adjust the capabilities of the product, and you should expect to have a public CTP ready sometime in the second half of this calendar year. And right now, we're planning to make this available through SQL Azure, the SQL Azure Labs site. Good. Moving on from the announcement into the next scenario that I want to quickly talk about. This one is around traffic. We started out with traffic, so I also want to have a scenario in here. This one is around fleet management, where you have a number of vehicles that you want to track and understand. You want to optimize their routes, their utilization. And obviously, you want to not just do that by the end of the business day. You want to do that continuously during the business day. And again, the advantages here are if you deal with a large fleet, your system needs to scale. And you have to deal with real-time data, sensor data that, for instance, the GPS systems from your cars, from your vehicles are producing. And again, I have a little demo to illustrate this a little bit more. Let me move over again into my laptop here and see whether I get this up and running. So we at Microsoft, who has been at the Microsoft campus in Redmond? A couple. OK. Let me tell you a little bit. If you go there, you will notice a number of shuttles that are just constantly driving around the campus and are taking people from one building to the meeting that they have in some other building on the other end of the campus. And for us, it's very handy because we don't have to drive. We just hop into one of those shuttles. Now, interestingly enough, these shuttles are instrumented with little GPS devices. And every couple of seconds, they're sending an update of their position, their direction, and speed to a central services coordinator. And what we did here for this demo is tapping into that data feed to understand the current shuttle position, and then also calculate a number of additional KPIs and metrics on top of that data. And since I'm not on CorpNet, can I do a live? Oh, come on. Do I have anything still running here? Let's see. OK, so there we have it running. We had some leftover process stuck in the background. So right now, I have a very simple query. I'm basically just tapping into the data feed that's coming from the shuttles, and I'm showing the shuttle number and the current shuttle position on the map of the Microsoft campus. And then all of these little checkboxes are StreamInsight queries that I have running in the background. And I can now selectively just enable or disable output from these different queries that I have running. One, for instance, might be I want to track shuttle 504 specifically. Right now, it's somewhere up there on 520, and it's moving southwards. I might also be interested in the shuttles that are close to building 34, because that's the building that I'm working at, and I want to see whether shuttles are around that I can just hop on. And one of the interesting features that we used here to power that experience is to use the SQL Server spatial libraries to define the geometry and geography of building 34 and to run proximity queries for the shuttles when they're coming close to building 34. And right now, we have about 3 shuttles close enough to building 34. I can also find the nearest shuttle again, which is a proximity query using this spatial libraries. And I can also run more kind of business-oriented calculations. For instance, I can, down here, I have a little control that calculates the percentage of idle shuttles right now. Those are shuttles that are not moving. They're just stuck for a period of time in a particular position. Those are the ones that we treat as idle. Right now, everything looks good. There's a very small percentage of shuttles that are idle. I can also take this to the next level and overlay the map with a grid. And then for each cell in the grid, ask the same question. How many idle shuttles do I have in a particular region on the grid? And I might also be interested in which regions on the grid do I have the biggest demand so that I can reroute shuttles from underutilized, from underserved areas to the ones where I have the highest demand. So that's, again, an example of a StreamInsight application. Again, all of these questions are driven by StreamInsight queries that are running in the background. And I'm just visualizing the output here in the dashboard. All right. So we looked at this. Two more scenarios that I want to walk you through real quick before we wrap up. The next one is a very important one. It's around power utilities and smart grids. I don't know from what regions you're coming. You might be already living in an area where your power utility is rolling out what's called smart meters, little devices that sit on top of your electricity supply and understand how much electricity you are consuming and how your appliances in your household are wired up to your power utility. And these smart meters typically talk back every couple of seconds to the utility to give an update of the consumption for each household to the power utility. And the utilities are using that in various different ways. So first of all, they want to understand what's the current demand in my grid, and do I have to fire up new plants, for instance, to produce more electricity? And they're also using that to better understand the behavior of their customers, and eventually are probably going to get much more dynamic in terms of the prices that they're using, at least for some of the consumers, so that they can drive demand based on prices in a more dynamic fashion. Now, some of the challenges around these scenarios is if you have millions of households where each household has a little smart meter that produces a bunch of data readings every second, you have to deal with quite a large number of data that you have to work with. And again, complex event processing, stream data processing is a key technology here that allows you to process all that data and filter out the data that's really relevant for you to go into the next processing stage. And you can do that, and there are various different scenarios in the utility space. For instance, if you have to update certain values based on previous consumption, if you don't have connectivity to a meter, if that goes into billing, all of that can be dealt with declaratively through link queries that you write for StreamInsight and that you deploy in the StreamInsight engine, where it can then work over the high volumes of data that are coming from those smart meters. And in particular, when you're working on a power grid and you're using stream data processing to understand imbalance in the power grid, it becomes essential for you also to understand these conditions in close to real time so that you can react quickly before you have an outage in a particular area of your power grid. So again, that's a key scenario that we see for complex event processing and stream data processing. The last scenario that I want to introduce you today is around retail, online and traditional. Everybody knows collaborative intelligence, for instance, from Amazon. If you go and order books, you get a bunch of recommendations based on other customers that have looked or purchased similar books to the ones that you are currently looking at. Now think about a scenario where I'm going into a grocery store, and on checkout, the agent is sliding all my goods, and the bill comes out. What would be the most appropriate coupon for me to print out today based on the current market basket that I'm taking out of the shop and my previous purchase history? So there are two ingredients to that scenario. The first one is historical data. What did I purchase before? And the next one is more real-time data. What are the current goods that I'm checking out today? And based on that, what would be the coupon that has to be printed to get me back into the store tomorrow? And that is a scenario that can also run with StreamInsight. In particular, the real-time aspect of that question can be dealt with very efficiently through StreamInsight queries that correlate the current market basket with your purchase history and can come up with predictions of what are the most appropriate goods for you to put on the coupon. So looking into the technology a little bit more now, what are the key ingredients there? What is the StreamInsight engine made up of? So first of all, it's a main memory-based temporal query engine. We already talked about that, and we saw a couple of the key temporal aspects like the windows that we have used in the market monitoring example. Other than that, the typical relational operations are supported. We'll see them on one of the next slides. We have an extensibility framework that allows you to plug in proprietary libraries. The one that we used in the fleet management scenario for the shuttle tracker, where the SQL spatial library is just a regular .NET library that we were using to do the proximity queries. The hosting and the deployment for StreamInsight is very lightweight, very flexible. You can run it, just the DLLs, in your application process, very lightweight. Or you can deploy it in a more server-oriented fashion, run it as a Windows NT service where multiple applications are connecting to the service and sharing the processing. A couple of the key requirements for the platform: it requires .NET 3.5 Service Pack 1 or .NET 4.0, CLR for the runtime, and the way that you write your applications, we've seen that is through .NET, C#, and Link. Visual Studio to develop, and the event flow debugger to do administration and monitoring of production deployments. So we've already looked at some of the StreamInsight queries, and I want to walk you through a couple of examples to call out what are the key operators that StreamInsight provides out of the box. The first one is a very simple query that takes two input streams, stream 1, stream 2, and joins them, correlates them based on IDs that the inputs carry around. That's a traditional relational join operation. Besides the traditional semantics of join, we are also looking into relationships between the events that we match in terms of timing. We want to make sure that we only correlate events that are also closely related in time with the join operation here. That's a twist to the relational semantics. The next operator that we're using here is just filtering out events based on a particular predicate, same semantics as in the relational algebra. Projections here, another relational algebra operation. So very simple query example here for the first one. The next one is very similar to the one that we were using in the market monitoring scenario. We're taking an input stream, and we're grouping it, we're partitioning it into substreams based on a particular field. And then for all of these substreams, for all of these partitions, I'm running these hopping window calculations that are recalculating, here in this case, averages over a field from the event feed that I'm getting from the input. So those are just a couple of the key built-in operations in terms of aggregation operations that we support. There's average, there's min, there's max, there's top K, summing, and counting. Those are the built-in aggregation operations that we support. And you can also write your own aggregation operations. For instance, if you want to do time-weighted averaging, you can do that through the user-defined aggregates. Why did we pay so close attention to being very flexible from a deployment perspective? Remember that you can host StreamInsight within your application process, but also run it as a standalone server. The key scenarios that we see for a larger organization is to have deployments at various different levels. And I'm trying to capture this here in this slide, where you might want to run an application very close to the data source and do that in a very lightweight fashion. There, you can do that by just running an application that embeds the StreamInsight engine and looks into the data that's coming in, for instance, from a sensor, does the initial aggregation, compression, and filtering before passing the data on to the next layer in the organization. And as we go more towards the center of the organization, you're typically finding more heavyweight deployments, more server-centric deployments. So if you go to the center of this chart here, you'll find typically IT-managed cluster deployments where multiple applications are sharing the data processing on the systems. And we are supporting that with the other deployment model for StreamInsight, which is the server-centric, instance-oriented deployment model. It's very similar to SQL Server or other NT services that are running on your system. In terms of the relationship between SQL Server, the SQL Server editions, and StreamInsight, so that's an overview of all the SQL Server workloads. And the bottom row here is the one with StreamInsight complex event processing capabilities. All the SQL Server editions have StreamInsight capabilities. But depending on the scale that you need, you might be fine with the scale that you get with Standard and Enterprise, which has a standard version of StreamInsight. For the truly high-scale scenarios where you have to deal with tens of thousands of events per second and very, very strict latency requirements, we would be looking towards the data center edition of SQL Server, where you get full-scale StreamInsight for your deployments. In terms of domain-specific solutions, we are working with a number of different partners from different verticals and different industries. And there are a number of different scenarios where we are collaborating with those partners. The first one is giving you more or less out-of-the-box access to different industry-specific data sources. So if you think, for instance, about the manufacturing space or the utility space, there are protocols like OPC that all of the various devices and data sources expose. So we're working with partners here like Matricon or OSIsoft to give you access to those data sources and make it easy for you to build applications with StreamInsight on top of that. And then, for instance, in the finance area, we're working with other partners to give you access to the typical data feeds that you find in the finance space, like, for instance, the FIX protocol. And if you have more questions around that, if you have a particular scenario coming from a particular industry or vertical, feel free to stop by after the session, and I can tell you more about what partner to work with in case you're interested. OK. So we're getting closer to the end. Let me use that slide. You've seen that slide before to just call out a couple of the key points again. So StreamInsight is Microsoft's platform to do complex event processing and to build event-driven applications on the .NET stack, Visual Studio. And the development experience, as I said, is closely related to .NET Visual Studio. You write your application in C#. You write your queries in LINQ, in language integrated query. The engine supports a framework that allows you to connect .NET sequences and other data sources as input or also as output to StreamInsight and feed your queries and consume the results from the queries that you're running. The engine, the StreamInsight engine, powers continuous standing query processing with very compelling throughput, data rate, and latency capabilities. We take away a lot of the pain that you would need to work through in terms of memory management or state management, parallelization, high availability, if you would want to write this yourself. This all comes out of the box with the StreamInsight engine. And in particular, when it comes to dealing with time, remember the windows that we talked about. All of that is built-in functionality that you can benefit from when using StreamInsight. So those are a couple of the key points that I want you to take home. If you need more information, these slides are available online as well. Just follow the links here from this slide. You'll find the main product page. You'll find our blog. If you're particularly interested in writing queries, I very much recommend reading the Hitchhiker's Guide to writing StreamInsight queries. The latest version is also linked from our blog. It takes you directly to the Download Center location on the Microsoft Download Center. And the last two links are to the documentation and to our samples that live on CodePlex. Another session that I want to call out that's also going to touch on StreamInsight is this session here, Dev 340. And besides that, I'll be at the SQL Server Programmability booth right after this session, and also tomorrow in the morning, and later during the conference. So if you have any additional questions, check out the booth, SQL Server Programmability. I'll be there and can answer questions for you. And with that, those are resources. And please do fill out the evaluation forms. It helps us to make sure that we're delivering the right content for you and in the right form that you need. OK. Thank you all. Thanks very much. Questions?